Hello and welcome to the Lego Mindstorms show featuring Microsoft Touch Develop. Well, actually it's vice versa. It's Microsoft Touch Develop, developed by Microsoft Research, featuring Lego Mindstorms. So it's all about the world's first Lego Mindstorms implementation of the Bluetooth protocol for Microsoft Touch Develop, an integrated development environment for everything that you can pretty much program on, and that's capable of displaying web applications like the Windows Phone, very famous, and Microsoft Surface, or any other device. So it doesn't matter if you have an iPhone, an Android, a Macintosh, a Linux PC, a Windows PC, a tablet, or maybe even an iPod Touch. I didn't try it myself, but I heard that it's possible. So what we did last time is showing a round trip about the NXT library I've written for Microsoft Touch Develop, which is capable of communicating with Lego Mindstorms Robota using the Bluetooth protocol. So let's have a fast look at it. Here it is. Edit. There was happening a lot to this library in the last couple of days, as you can see in the test method, in the main method. A lot of new stuff is in here. If you're interested in the way how this library works, please have a look at the last video. It shows a simple introduction using the play tone methods and a simple piano using to play notes or tones on the Mindstorms robot. So what happened to the library? First of all, there are a lot of new functions. As you can see here, we are able to get the firmware version, the protocol version used by the firmware. We are able to retrieve the battery level, which is really a necessary or important thing to see how much power we have left on the robot. We can even get specific device information, that is the brick name, the Bluetooth address it is communicating with, the signal strength, and even the free user flash memory that is used to store programs on the brick itself. So actually we can't use these features on the Microsoft Surface RT or even the Microsoft Surface Pro or even any other device that is not a Windows Phone 8, because the Bluetooth protocol is only supported by Touch Develop on the Windows Phone 8. So what we're doing is we switch to the Microsoft Windows Phone and load the NXT library, hit edit, and run it. Well, that was not so exciting at all, but what you can clearly see is there happened a lot. We played the tone at 440 Hertz, that is an A sound. We retrieved the version, it's firmware version 1.31, the protocol version 1.124, and we know about the battery level. 9000 millivolt would be the maximum, so we have pretty much left. And we got some device information like the brick name, it's NXT, impressive. The Bluetooth address, the signal strength. I really don't know about the signal strength, because no matter what system I use, Windows Phone, or even if I use Bluetooth with the original NXT software, the Bluetooth signal strength is always 0. Maybe someone knows what this is all about, then please drop me a message. The free user flash, we got a lot of flash memory free for our own use, so there's a lot we can still do. So how does this work? We're going back to the Surface because the display is a little bit bigger and we can show more, and have a look at the new methods we got, like getting the battery level. So what's happening here? You can see there happened a lot to the library. For instance, the init command method now recognizes a couple of numerics, like a command get battery level, a command type, direct with response. And how does this work? So in the real world, in a world with a Visual Studio, for example, we would use enumerations. And this is exactly what open source libraries that communicate with the NXT brick do. They use enumerations for the specific command types and the commands that are sent to the NXT brick. So we don't have enumerations in Touch Develop, but what we do have is art. So art, I would say, is normally something like a picture, but art can be a lot of more, like here. An art can have art type, and the types are declared here, like a number, a string, color, picture, or even a sound. So what we are interested in are numbers. So what I did is I implemented the specific commandos that are sent to the brick as art number types. So to recognize them, I prefixed them with cmd, like command, and get battery level is the specific command that is sent to the brick. So the values are decimal. I used the comments to store the hexadecimal value just for documentation purposes. So there are a lot of commands like get battery level, get current program name, get device info, get firmware version, get input values. Get input values is something that we are going to use later on in this video to actually show how to access sensor information. There's a lot of more stuff happening here, like command play tone. Last time we simply used the init command method and what did we put them there? The value 3. Now we are using something like the enumeration type, in this case an art number type. So it's easier to read and recognize the code. So furthermore than command, there are command types like direct commands, with response, without response, a reply type, and system commands, with and without response. It is necessary and important to know that the NXT bricks knows about commands that do not send responses, or even that are not necessary to send some responses. Other types do have response packages that are sent to the initiator of a command, because maybe you want to read values of a specific sensor, and the sensor information have to be parsed in some way, and so you can retrieve response buffers, but you have to initiate the command with information about whether or not you are going to parse a response. There are a lot of more enumeration types here, like the sensor mode, which we are going to need later on in this video to actually read out values from the sensors, and the ports that are used to connect the specific sensors. You can see them here on the brick. There are port 1, 2, 3, which are used as input ports, and A, B, C, which are used at output as output ports. And there are default values, like the first sensor port here is the default port for touch sensor, so you would simply expect a touch sensor connected to the first sensor port. In this case, using this robot as a designed Lego Mindstorms robot, you can see here touch sensors. We're going to show you right here, and the touch sensor is triggered each time the robot makes a step, like so. So the robot knows the step is finished through the touch sensor and can initiate another step. And both of the touch sensors are connected through a Cat5 cable, something like that, to the brick, to port 1 and 2 in this case. So furthermore, the sensor ports, we have sensor types like angle, custom, light, active, light, inactive, low speed, no sensor at all, reflection, sound, dBA. A switch is what we're going to be interested in. It can be actually an NXT switch or even an RCX touch sensor, which is the predecessor to the NXT brick from Lego Mindstorms. So, coming back to our main program, where is it? Here it is. What we first did was connecting to the brick and playing a tone. We already know that. The play tone method itself has gotten a little update, so it uses the enumerations to actually play the tone. You can see them here. Command play tone, command type direct without response, because we don't need actually a response. The frequency and duration is encoded as U in 16 into the command buffer, and then simply send. So we also have a send command, and furthermore a send command with waiting. There it is, send command and wait for asynchronous commands that trigger response buffers. What's really fancy is that TouchDevelop also supports contracts. So we can define a contract that requires the frequency being bigger than or equal to 200 and lower than or equal 1400, which actually triggers an error if the method is called with a frequency out of this range. Very cool. So, what are we doing next? We are retrieving version information. GetVersion is the entry method, and GetVersion does simply nothing more than initializing a command with a command get firmware version, a command type with response in this case, and sending. The send command and wait method not only expect the command buffer itself, but also the size of the response buffer, in this case 7 bytes. The information at which position in this response buffer which information is contained can be obtained from the original documentation of the Lego Mindstorms Bluetooth protocol document. At position 6 and 5, the firmware information is stored. At 4 and 3, the protocol information. What's a little bit tricky if you don't know this concept is handling with MSB and LSB values, because the byte order is normally inversed in this protocol. You simply will have to bing for information about MSB and LSB for byte and bit order and positions to understand what this is all about. So, next thing. The firmware and protocol version, what we're doing next is retrieving the battery level. It's almost boring because every method is pretty much the same from the way it works. We're initializing a command buffer, in this case with the command get battery level, and also with a direct command with response. In this case we're expecting a 2-byte response buffer, 5-byte response buffer, sorry, and retrieving the battery level by parsing the buffer's content with a getUint16 method that does a little bit of encoding, or decoding in this case. Is there anything interesting left in this information block? Well, actually, getDeviceInfo does exactly the same as all the other methods, but to make this library a little more interesting, we're going to do something very, very cool. For example, we have a method here that's called startProgram. So, startProgram takes a file name as an input parameter, creates a command buffer with a command startProgram and a direct command without response. And what we're doing here is we're encoding the file name into something the command buffer will recognize and make sure it gets the correct extension, RXE. If you already put the extension into the file name, that's perfectly okay. If not, the RXE extension will be added automatically. And what we're doing then is we copy the file name that's encoded into the buffer and simply send it to the brick. That's pretty much all. So, what's all about these file names? Let's have a look at the brick itself and hope that you can see the display. Here it is, my files, and my files has a subdirectory software files, and already on this brick are several files contained with a lot of programs, like the RoboGator1 or the ShooterBot A or RobiBot1, and this is what we're going to try to start, RobiBot1. The way the Lego Mindstorms robot works is normally you define the program on a PC software, like the Lego Mindstorms software itself, or maybe Microsoft Robotics Development Studio, which is a very cool robot development environment that you can use to even program the Lego Mindstorms robot. And once you coded the program, you upload it to the brick, and then you have it here in the list, and you can start it either on the brick itself by using the keys here, or you can start it via Bluetooth or via USB. What we are doing is we are going to try starting this with Touch Develop. Let's switch to the Windows Phone and extend the main method by starting the RobyBot1 program directly on the brick. So what we're doing is we're editing the script, going to the main method, here it is, and adding some code. Alright, so we need a new line and maybe something like a comment. It's always good to comment your source code. Start program. Alright, and what we're doing now is simply code. Where do we have it? Start program, edit, and name the program we want to start. In this case, RobyBot -1. And actually we don't need any response here because it's simply a command that's sent to the brick, and that's pretty much all. So that should be it. Let's run the program. Whoa! Whoa. Calm down, calm down. Well, that was a great test, wasn't it? Let's have a look at the output of the library. What did it do? It actually, well, there's no output here because we didn't make it output anything that's of any interest. So, no matter, but what we just presented here was the ability of starting programs with Microsoft Touch Develop on the Microsoft platform using Bluetooth, controlling the Lego Mindstorms robot. What's cool, by the way, is I just added some code using my Windows Phone 8. When I'm going back to the scripts overview, you can see here that some synchronization takes place. And if I go back to the Surface RT, you just saw a little green bar flashing up here. And if I go back and edit my NXT library and have a look at the main method, the start program also is synchronized to my RT device. This is because everything you do in Microsoft Touch Develop is connected to the cloud and synchronized between the devices. However, you must really take care about what you're doing here, because if you're deleting something on this device and hit synchronize here or let it automatically synchronize, it might happen that the code also gets deleted here. I almost lost the NXT library because I didn't fully understand the synchronization method, but I was lucky. However, what we are doing up to now is simply reading information from the brick and starting a program. What would be really cool is getting some information about sensor input. And I prepared a little script to show how this works. And this also works shows why I'm using the Microsoft Windows Surface RT in this case, also to develop the NXT library and not only the Windows Phone brick, because there's a huge difference in how both of these Touch Develop versions work, because on the RT device or any other device that is not the Windows Phone, I'm able to use the beta version of Microsoft Touch Develop, and the beta version also already supports asynchronous methods. So if I'm using asynchronous methods with async and await pattern, I cannot use the Windows Phone 8 device, but have to switch back to my RT in this case. And I'm using RT and not my notebook because my RT is touch enabled and my notebook is not. So what we're doing is we're adding a new method like this, go, and give this method a name. And I'm gonna name it test sensor touch. So I will make it public because if a method is public, I can trigger and run the method directly. You will see later on. And I mark this method as async. So this method doesn't need any input or output parameter. I won't need them. And the method will work for itself. It doesn't need the main method because it's just for testing purposes and to show you how to work with sensor input data. And what I'm doing here is, first of all, I need to initiate the connection to the brick. We already have a method for this. We hit code and select the connect to brick method. And here you can see the connect to brick method is an asynchronous method, so it's prefixed with the await call. And this is why I can only do this on the RT, because marking the whole method as an asynchronous method like I did here, async action, is only possible on any other device than Windows Phone 8. I guess it won't take that long until Microsoft supports this pattern also on Windows Phone. Well, so now that I'm connected to the brick, I will have to set the input mode. This is necessary because the brick will have to know what kind of information I'm going to expect and what kind of type I'm going to expect. So I will do just this code. Where do we have it? Get input value, set input mode. Here it is. So it's documented. You can see here in the light blue bar, the first input parameter is the port. We're going to address the type, so the type of sensor that is connected to the port, and the mode in which the response is going to be expected. So let's have a look. First of all, in the input mode parameter, the port, I have my enumerations. So they are stored in the art section, and there are a lot of different art numerics that we can choose from. And to make it more simple, I switch over to the Explore tab, and there they are. What we're going to do is we are going to trace the sensor port number 1, because this is where the touch sensor is connected to. And where are they? Here are the different sensor ports. I select the sensor port number 1. Here it is. And next thing is the type. So what we are going to trace is the sensor, the touch sensor, which is known as the type switch. Alright, so the art section and explore. And we can also use this search bar here if you're going to search for something that we pretty much know what is named. In this case, it's sensor type, the switch type. So I'm going to enter switch here, and oh, there it already is, sensor type switch. This is what we're going to read. And last but not least, I'm not interested in any raw values that are triggered by the switch, because actually it's possible to return values that also have information about how much the sensor is pressed or anything else. What we are going to do is we are simply returning a value that says yes, it's pressed, or no, it's released. So what we need here is the sensor mode boolean. Let's have a look at the art section and explore what we're going to have here. And sensor modes, there are a lot of them. For example, Fahrenheit, full scale, angle step, and also sensor mode boolean. Alright, so we just set the input type, and now we have to the input mode, and now we have to call the method to actually read the input from our brick. For this we have a method called getInput get input values. Here it is. So, and what does get input values do? First things first, it's necessary to address the port. It has to listen for input, and then it returns a buffer. So we are going to add the port, the sensor port 1. What's really cool about touch develop is the IntelliButtons buttons and the way they work, because methods or values I'm often using are put first into the list. So here you can see sensor Boolean, sensor port 1, sensor type switch, all of these which I used before, and it's very easy to select them here. Sensor port 1 is the port which I'm listening on, and it returns a buffer. So we are going to store our buffer in a variable here. It's initially called buff, and I'm absolutely okay with that. Funny thing is, this is an asynchronous method. Asynchronous method can only return one response variable. Every other method is actually capable of returning more than just one response variable. Let's have a look at it. I'm hitting dismiss here. And don't be afraid of doing this. We can go back to the method we are developing at any time and have a look at get input values. So because it is an action, an asynchronous action, it can only return one variable, response buffer. If I tried to add any other response type here, I'm going to get an error message saying, hey, asynchronous methods can only return one response type. Try something else. Well, I did, and the result is, well, let's have a look at get input values sensor state. It should be sensor state. There it is. The sensor state actually is not an asynchronous method, but a simple method that gets a buffer as input, and it puts out a whole lot of variables: valid, calibrated, sensor type, sensor mode, raw value, normalized value, scaled value, and calibrated value. All these information are retrieved from the brick when it got an input, sensor input. And here's a little bit of decoding the values we have in our response type into these output variables. There are no checks taking place here because they are not really necessary at this point. So let's go back to our test method, test sensor touch. Here it is. At this time we only have a buffer. So what we're doing now is we are trying to read or parse what this buffer contains so that we have values we can work with actually. And this is really simple because everything we have to do is hitting the code IntelliButton button and find our sensor state. There it is, method. And actually, touch develop is intelligent enough to recognize that buff is our only buffer variable we have at this point. And since the sensor state method expects a buffer variable, it already put it in there. Also, we get a little hint here that sensor state returns 8 values in total, and we can use them simply by putting the var button into place to save them to locals. So this is really easy. I'm hitting the store in var button, and what happens here is that I'm getting variable list, a list of variables with all our output variables we defined in the sensor state method, like valid, calibrated, sensor type, sensor mode, raw value, normalized value, scale value, calibrated value, all of them returned by the sensor state method. So I don't want to rename them, so I'm perfectly okay with these, and put another line there, because what we are really interested in is if the sensor has been really touched or not, or switched, if you like. So what we're doing is we are working with a scaled value, and and checking if there is a 1 in the scale value or not, because 1 and 0 is what it uses for true and false. So if condition, if scaled value equals 1, then we would like a notification on our wall that states that the sensor has been touched or pressed in this case. So what we're doing is we're adding a string here and name it pressed dot, and need to post this on our wall, post to wall here. And in any other case, if the scaled value is not equal to 1, we're going to add a notification, add a notification to our wall that states this sensor has been released. That is. So let's post this also to the wall. Here it is. And that's pretty much it. So to review this little method, we named it test sensor attach and made it public so that we can trigger it manually. We connect to the brick, set the input mode to sensor port 1 and to the sensor type switch and to the sensor mode boolean to tell the brick that we expect the boolean value to work with. We retrieve the buffer by executing the get input values method on the sensor port 1 and interpret the values sent with the response buffer with the sensor state method to decide whether the switch is pressed or not. So actually, as you already understood, we cannot execute this script here because the Windows RT is not supported for Bluetooth. So we are heading back to our script section to make touch develop automatically sync what we just did, and go back to our Windows Phone, waiting for the synchronization to take place. In any case, if the synchronization doesn't work automatically, which it should, you can go down to the Chat and Learn hub. It's not that intuitive to understand that, but the settings button can be found here, like that. And there you have a button to synchronize manually, which you can do anytime you want. So we are going back to the NXT library, going to Edit, and what we're hopefully finding here in the script section is test sensor touch method, like here, with an open play button because we declared this method to be public. Just to make sure, let's have a look at it, and here it is, just like that. Alright, now it's going to be a little bit complicated because the sensor is already built within the robot, so I will have to try showing you what this is all about. I'm taking the robot here, and this actually is the touch sensor, the sensor switch, which is connected to port 1. So now it's released, and now it's pressed. Released, pressed. Alright, I'm going to have it be released, and execute the sensor method here, and it absolutely correctly states it's released because I'm holding it here. It's a little bit tricky, but you understand what it's going to happen here. So going back, I'm doing the following. I'm pressing the sensor like that, and once again, where it is, oops, not so fast, and running the test sensor touch method like that. It's pressed, and it's correctly stating the sensor is pressed. Well, okay, the robot didn't dance around, and we didn't make it move here, right, with the touch develop environment. But what we showed is that we are really capable of getting sensor information, and hey, it's capable of starting programs. Come on, let's do that once again, because it's so damn cool. Where is it? Main method, start. Beep robot, move robot, make funny lights robot. That is so damn awesome. Unfortunately, this is not my robot. A friend of mine landed me, and I will have to return it in a couple of days, I guess. So there is not much time to complete this library. At least not now at this moment. So I'm going to release the library to the public. You can work with it, extend it for yourself, build maybe some UI environment with a lot of images and animations and such, to get full control about the robot. I will try to extend the library to the point that pretty much everything you need to control the robot will be there and can be used. So what's left to say? I guess there will be another 1 or 2 videos to be released. Stay tuned. Put comments below. I'm really interested if anyone uses this library or would like to use this library and what you think of it. Have fun with it and see you soon. Bye bye.